You're welcome to today's class. The last class, we demonstrated a C program for a two-dimensional array. We are still on multidimensional arrays. So in this class, I'm going to take you through three-dimensional arrays, right? So I'm just going to do for what? Three dimensions, right? So three-dimensional array, three-dimensional array. So now, what do you have as a three-dimensional array? If this is um, right, 0, 1, 2, 3, then you have 0, 1, 2. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. Then we have this as one dimensional. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, this is a one-dimensional array, and this is how it is represented in a linear memory. So you have the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are the indices, right? Now, this is the two-dimensional. So, and this is what? J equals to what? Column, right? And this is I for row. That's what you have. So this one is two dimension, and then this is one dimension. Now, what we want to do today is three-dimensional. Now, a three-dimensional is array, a two-dimensional array on top of each other. So if this is like your chessboard, or this as it is, now imagine this complete one again on top of it. So you are stacking. You have your chess board that you are using to play your chess. Then pick another chess board and put on top of it. Another example is what? A story building. So for a three-dimensional array, you have something like this, right? Um, then you have this. So you're having this. Then you're having this, and then this, and then this. So I will have this, and then this. So I can now have 1, 2. So I have this, and then I have this. So I now have 0, 1, 2, 0, 1, right? Um, then, so here I have 0, 1, and then you have this. So this is a three-dimensional. So I have 3 dimension. So 3D. So this is a three-dimensional array. Now I have this here. So 1, 2, 3, 4, 5, 6. For the first one. So the second one too is going to be 6. So you are putting this on top of this. This is a three-dimensional array. This is a two-dimensional array. So you are stacking this. So this one is what you are putting on top of each other to have this 1, 2, 3, 4, 5, 6, and then this down one is this on top of it. So you're having, these are two-story building, first floor, second floor. That is basically what a three-dimensional array is. And the syntax for a three-dimensional array is data type, right? Then array name, Then you have the first one, depth, right? Then you have row, and then you have column. So this is the syntax. So this is the syntax for a three-dimensional array. You have the depth, which is the height. Then you have the row, which is like the length. And then you have the column, which is like the breadth. Our world that we are living in is a three-dimensional array. Now, when you now go to four-dimensional array, that will now be space plus time. So all these three are known as what? Space. Then when you now add it time, that becomes four dimension. But we are not going to deal with that in this class. So we are just going to stop at three-dimensional array. Now, how do you take this three-dimensional array and then flatten it into a one-dimensional array for it to enter into the memory? To achieve that, we are still going to use another formula, right? So that is what I want to show you. So in that of, we did that of two dimensions. So for that of three-dimensional array, we are going to calculate the index. You know, I told you to get the address, you have base address. Base address equals to the any address is always base address plus index, right? Multiplied by what? Size of data type. Size of data type. That is how you calculate the address of any. So if we have this 100 as the base address, how are you going to determine these other addresses for these other elements? So this is it. Now, to get this index, we need another formula because this is the flat index, right? So to get this index, we will say I, so the flat index equals to what? I times, so put this in bracket, row multiplied by column, right? Plus j times column plus k. That is how you are going to find. So this I becomes the index for the depth. This I becomes the index for the depth. This j becomes the index for the row. And then this k becomes the index for the column. Right? With this formula, it therefore means that when you are declaring an array, a three-dimensional array, you must always provide the row and the column. You might omit this and then initialize this array. The compiler will use the initializer to determine what? The depth. But you must always provide the row and the column. Like a two-dimensional array, you must always provide the column. You can omit the row after you initialize. The compiler will use that initializer to determine what? The row. So for this one, because of this formula, I must always have row and column. Now, if I am to find the address of 12, let's say I put 12 here. Let's say I have 12 here, right? I have 12 here. And I want to declare an array, this array for a three-dimensional array. It will be what? Int, let's call this one cube. Let's call the array int cube. So for a three-dimensional array, depth will be what? 2, right? And then the row will be what? 2. And then the column will be what? 3. So this will give us, this will be what? A three-dimensional array. Like this one, it will be this. That will give us a total element of what? 12. That will be 2 times 2 times what? 3. That will be what? 12. Total element 12, which is what you have here. Now, to get this index, in order to determine the address of any of the elements, we have to use this formula. So let's substitute the values. If I am having my I is the depth, so I will say this is the size, row 2, depth 2, row 2, column 3. So what would be the value of the last element? So if I have, that would be what? Cube. If I have cube, then I put here 1, and then I put here 1, and then I put here 2. So what will be the value of this element? What will be the value of this element? Because if I'm having 2 depth, 2 rows, and 3 column, it means the indices will be what? 0, 1 for the depth, 0, 1 for the row, and then 0, 1, 2 for the column. Now, when I write this value, what will be the value of this? To determine that value, what I will do is, this is depth. I will come to this formula. So I will come to this formula. So I am going to wipe this side. I will come to this formula. The index I is 1. Multiply by what? Row. Row is 2. Multiply by what? Column. Column is 3. So I'll put this in bracket. Plus J. J is what? The index for row. And that is what? 1. Multiply by what? Column. Column is what? 3. Plus K. K is the index for column. So, and what is that? That is 2. So that is this. So 1 times 2 will give me 2 times this will give me 6. Plus 1 times 3, that is 3, plus 2. So this will give me 9, 11. So this will be the indices, 11. Now, when I take this index and I bring it here, so it means this is the 11th. If the index is 11, it means this is the 12th element. So which means this one. So this one will give me what? 12. Now, how will I be able to calculate the address of this now? I now bring this into this place. So 11. Data type is what? 4 times 4. Base element is 100, right? This times this, that is 44, plus this, 104. 104. So this is what? 144, I mean. Now, if you do this again, just like we did in the 2-dimensional array, you will get 144. So how to extract the element of every index, of every indices here, is using this formula to be able to determine the flat index. This is for depth, this is for row, and this is for column. Substitute them into this place, and it will give you the value for any element. That is how the compiler is able to determine the element once these indices are given. So with this now, I can access the last element, which is what? 12. So that is what I want to show you on how you can flatten a 3-dimensional array to a linear memory and store it in the memory. So our world is a 3-dimensional array. So consider this as a building with 2-story building. What we just did now is 2-story building. Each of the floor has 2 flats, and each flat has 3 rooms. Just think about it that way. And then you can locate any value that you have in any of these places. Our libraries use this concept of three-dimensional array for you to trace books on the library shelves. So that is what I want to show you in this class. In the next class, I'm going to now write a C program to be able to access the element of this array and project them on the screen. So to see you in the next class. Bye-bye.